Good morning, everyone. My name is Professor Sachin B, working as an assistant professor in the Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. In today's session, I'm going to start with a new topic, projection of solids in engineering graphics, bearing the subject code of 18 EGDL 15/25. In the last session, you people have come across projection of points, projection of lines, projection of planes. In this session, you people come to know about what is the projection of solids, how to project the solid, and what are different types of solids, and how the construction of solids will going to play a major role in engineering drawing. Now, when it's come to the projection of points in a single entity with no dimension. When it's come to the lines is an entity which have only one dimension, that is nothing but the length, and the planes is an entity which consists of two dimensions, that is nothing but the length and breadth. And next, when it's come to the solid is a three-dimensional object which consists of length, breadth and thickness. Means here three-dimensional object means three entities were present, that is nothing but the length, breadth and thickness is get involved, which is bounded by rectangular faces, which is bounded by a plane or a curved surfaces or combination of both. Means solid is a three-dimensional entity which is consists of length, breadth and thickness, which is bounded by a plane or curved surfaces or combination of both. Means here they are saying it is bounded by a plane surface or curved surfaces. That is the definition of solids. Next, when it's come to the solids classification. When it's come to this classification of solids, here solids are classified into two types. The first classification is nothing but polyhedrons, and the second classification is about solids of revolution. When it's come to the polyhedrons, a polyhedron is a Greek word, that is nothing but poly stands for many, hedron stands for faces. Means polyhedron means many faces. Polyhedron means many faces. In that, these polyhedrons are the solids bounded by faces or planes. Means it is bounded by faces or planes. In some of the cases, if it is bounded by equal faces or same edge of containing the same edge, they are called as regular polyhedrons. If the faces are similar to the opposite sides, they are called as other polyhedrons. In that polyhedrons, we have one more classification, that is nothing but the regular polyhedrons. When it's come to the regular polyhedrons, if the faces are equal and its edges are regular, means if the polyhedron consists of equal and equal faces and the edges are regular, they are called as regular polyhedrons. For that, examples are tetrahedron, cube, octahedron, dodecahedron, icosahedron. Now this is the tetrahedron, and clearly observe the tetrahedron over here. In tetrahedron, I have written over here, the tetrahedron consists of four equilateral triangular faces. You can observe here, this is one face, this is another face, this is one more face. Means it consists of three faces equally distributed and in the front view, and you can observe at the bottom face, you can clearly observe one more triangular face is present over here. Means it consists of four equal triangular faces. And similarly, when it's come to the cube, cube is also called as hexahedron, which have six equal square faces. This is the cube, which consists of six equal square faces. Means equal faces are present. Next, when it's come to the octahedron, octahedron is in a solid which consists of 8 equal triangular faces. Means in octahedron 8 faces will be there. Those 8 faces are regular faces which are triangular faces. Next, when it's come to the dodecahedron is nothing but it's have 12 equal pentagonal faces. Dodecahedron have 12 equal pentagonal faces. Next, the last one is icosahedron is nothing but icosahedron is a solid which consists of 20 equilateral triangular faces. Means 20 faces are present. Those 20 faces are nothing but are regular faces, which are equilateral triangular faces. In one more classification, when it's come to the polyhedrons, are nothing but other polyhedrons. In other polyhedrons, the opposite faces are similar, but the faces bounded by both the opposite faces are dissimilar. When it's come to the other polyhedron, the first one is prisms. When it's come to the prism is in a solid. They have a base and a top face of similar shape bounded by a rectangular faces. When it's come to the examples of prism, we have triangular prism, we have square prism. This is the triangular prism. You can clearly observe this is the triangular prism. You can observe the base at the we have triangle, even at the top face we have triangle. Next, square prism, pentagonal prism, hexagonal prism, etc. And next is in the other polyhedrons we have pyramids. When it's come to the pyramids are the solids which have the base. One base will be there. To that base, the equilateral triangular faces are get bounded over there, and those triangular faces are get connected to the apex or the vertex of the pyramid. Means since pyramid, a base will be there. For that base, the triangular faces are get bounded. Those triangular faces are get connected at the top of the vertex or the apex. That is called as the pyramid. You can clearly observe here. This is the square pyramid. This is the base part present over here. You can clearly observe this triangular faces from the edges of that particular pyramid. From all the edges of that particular pyramid, a triangular face is get bounded. That is get connected to the vertex of the pyramid. That is about the pyramids. When it's come to the examples, triangular pyramid, square pyramid, rectangular pyramid, pentagonal pyramid, hexagonal pyramid, etc. This is regarding about the other polyhedrons. Next is about one more type of solids, that is nothing but solids of revolution. When it's come to the solids of revolution, here in solids of revolution, these are the solids that are generated by rotating a plane figure about one of its edges. For that, very good example is cylinder. And you can observe the cylinder will be get rotated by a rectangular face by fixing its perpendicular axis at the midpoint or at the center. Then you will going to get a cylinder by rotating it in clockwise direction or in anti-clockwise direction. When it's come to the cone, to generate the cone, right angle triangle is get fixed. With that right angle triangle, we keep on rotating that right angle triangle. Here in the right angle triangle, the hypotenuse is get inclined, due to which the conical shape is present in cone. Means by rotating the plane, you will going to generate the solid. When it's come to the sphere, a semicircle will be there. That semicircle is get rotated in its diameter to generate the sphere. That is about the solids of revolution. And one more thing, if people have already come across the meaning of projection, means in the first module itself, projection of points and lines, you people have studied, even projection of planes. The meaning of that projection is nothing but a Latin word which means throw forward. Means if you are projecting the object, means you are projecting the view of that particular object to the plane of projection, whether it is in front view, whether it is in top view, whether it is in right profile plane, or whether it is in left profile plane. Means you are projecting the object or you are throwing forwarding the view of that particular object. That is called as the meaning of projection. Okay, the next is about the methods of drawing the projections of solids. In the last you people have come across regarding about the prisms, pyramids, and how the prisms and pyramids will going to look. Now let us know about what are the methods are required to draw the solids. Are required to draw the projection of solids. There are two methods are required to draw the projection of solids. In that, first one is change of position method, and the second one is auxiliary plane method. In your syllabus we are following change of position method. They are clearly indicated that we need to follow that change of position method. We are not following this auxiliary plane method. But change of position method is nothing but here we are changing the position of the solid in 3 different stages to get the final position of the object. That is the change of position of solid. For example, this is the first position of the solid. Next, in the second position, I am going to incline the solid like this, and the last position, the inclination will be in different manner. Whether it is to the HP or horizontal plane, whether it is to the vertical planes. Means to get the final position of the object, we are changing 3 successive positions of the solid. That is called as change of position method. This is the first position, next in the second position like this, and the last position like this. In the first position, after keeping the object on horizontal plane or vertical plane, we need to go for projecting the front view and top view of the object. Again, when it's come to the second position, in the second position, again I am changing this object like this by incline to some angle to the HP with reference to the horizontal plane. Again here you need to go for projecting the front view and top view of the object. Again in the last position, by changing the object or position like or tilting the solid like this, again you should go for projecting the front view and top view of that particular solid in that position. Means in 3 successive positions you should project the views of the solid. That is nothing but the top view and front view should be projected to the respective planes. That is change of position of method. Next is about auxiliary plane method. When it's come to the auxiliary plane method, object is kept in a simple position. With the help of one or two auxiliary planes, we'll going to project that particular object in by generating the different views. Means you can clearly observe here in auxiliary plane present simple position, the object is kept, and with the help of 2 auxiliary planes set up to get the different views of the required position. Means here the object is kept like this by bringing the auxiliary plane. Means in change of position method, the object is get moved. In auxiliary plane method, the plane will be get moved to get the different views of the object in required position. That is the difference between change of position method and the auxiliary plane method. Next is about the difference between the prism and a pyramid. Before going to the construction of any of the solids, in your syllabus you have prisms and pyramids. In the solids chapter, when it's come to the prisms, you people should know the clear identification of the faces or the edges or the what are the bases, how it will going to look. When it's come to the prism, we already come across about the definition of the prism. This is I have written the triangular prism over here. You can clearly observe the diagram. This is the base part. Means this is the base part what I have written over here. These are all the base edges. This is triangular prism, means 3 base edges were present, and next is we have it is bounded by the rectangular faces. You can clearly observe 3 rectangular faces over there. It is bounded by 3 rectangular faces. These 3 rectangular faces have the vertical longer edge. You can clearly observe here. I have written the arrow to indicate that vertical longer or lateral edges. You can call it as vertical or longer or lateral edges. This one is vertical edge, longer edge or lateral edge, and this face is the rectangular face. You can observe the rectangular face present over there. And here the base, for the base, the top face is opposite for it. You can clearly observe here, and the base have the same shape. That is nothing but the triangular shape is present over here, and for the top face also the same triangular face is present over there. Means in triangular prism, the base is triangle and the top face is triangle. When it's come to the square prism, the base is square and then also in the top face will be square, but it is bounded by the rectangular faces. That is about the prism. When it's come to the pyramid, you can clearly observe here I have written the diagram of square pyramid. Square pyramid. When it's come to the pyramid have one base which is bounded by triangular faces and get connected at the apex or the vertex point. You can clearly observe here, this is the base, one base is there this is about the square pyramid, means square type, means in the base part it is a square shape is present over there, square shape is present over here. This is the base part. For that base part, 4 base edges are present because it is a square. 4 base edges are present. And the next is about these inclined lines, or the inclined edges that are present over there, they are called as slant edges. These inclined edges are called as slant edges. Means in square pyramid you will going to get 4 inclined edges from all the 4 corners of the base part. Those are called as slant edges. And here again you can clearly observe that it is a square pyramid. From all the faces we will have a triangular faces are bounded, means 4 triangular faces are present here. These are the triangular faces. These are the one triangular face, second triangular face, one more is at the back and one more at the ear. Means 4 triangular faces are present. And one more thing, while differentiating between the edge and the corner, in many of the problems they will going to ask for construct the object based on resting on its edge, construct the object based on resting on its corner. During that time many of the students will going to commit mistakes. To overcome those kinds of problems, you can clearly observe here the edges present over here. You can clearly observe in any of the diagram, whether it is a pyramid or whether it is a prism. To create a corner, 3 edges are necessarily required. You can observe any of the points. This is one of the corner, one more edge here, one more edge here. Again here you can observe here 2 edges were present at the top and one more vertical edge is present. Means to get the corner point, that is the meeting point of 3 edges, we will going to create a corner. That is the one of the major difference to write any of the diagrams in its corner position or in the edge position. When it's come to the edge, you can clearly identify the edge. There is no much complicated thing in the writing the edge condition, because it is resting on edge means you are resting it is on edge itself. If it is resting on corner, you people should know that corner means there will be 3 meeting points should get connected to it from the 3 edges. That is nothing but the corner. This is the major difference between and some of the things present in the pyramid and the prism, because these are necessarily required. When it's come to the pyramid problems, they will clearly ask the question like this: it is resting on one of its slant triangular face, one of its triangular face, it is resting on slant edge, it is resting on edge, it is resting on corner. In similar fashion, when it's come to the prism problems, it is resting on one of its base, it is resting on one of its base edge, it is resting on one of its base corner. Again that corner is get inclined to some angle. And also one more thing, in the prisms and pyramid, from the apex point in the pyramid, from the apex to the base center, an axis line is generated. With the help of that axis line, they will go for the many of the constructions. Even in the prisms, from the top face middle point or the meeting center point to the base center point, will going to draw the axis. In many of the views, axes are not visible. In some of the views, axes are visible in the problem. This is regarding about the difference between a prism and a pyramid, and about the methods of drawing the projection of solids. Okay, now let us continue with the first problem in the pyramids, that is projection of solids. But when it's come to the pyramid, in your syllabus we have only on 3 cases, that is square pyramid, pentagonal pyramid and hexagonal pyramid, with different kinds of positions they will going to ask. I am starting the first problem on the square pyramid here. Now I am going to read the question. A square pyramid of 35 millimeter sides of base and 65 axis length rest on HP. While reading the question, it is very much important where the solid is get rested, or where the solid is kept on which plane, whether it is on horizontal plane or vertical plane. Here they have given that a square pyramid of 35 millimeter sides of base, means base of 35 millimeter, and axis length 65 rests on HP, means you should underline this, it's resting on HP, means horizontal plane, means the square pyramid is completely resting on HP, And next I'll going to continue with the next sentence. On one of its edges of the base, means here they are clearly mentioned it is resting on edges of the base. This should be get underlined because these things are very much important to solve the problem. Which is inclined to VP at 30 degree, means till here till the full stuff I read the question, means here a square pyramid is there which consists of 35 millimeter of base sides and 65 mm axis length. Rest us on HP. It is clearly they are saying it is resting on HP on one of its edges of the base, on one of its edges of the base, which is inclined to VP at 30 degree. Now till here I am going to solve the problem by using the method of change of position method. Now I'll go for drawing the XY line. I'm drawing the XY line here. Above the XY line it is VP, below the XY line it is HP. In the problem they clearly saying that a square pyramid of 35 mm of sides of base. Now this is the square pyramid. Now it is, I am keeping the square pyramid on the horizontal plane. My left hand is the horizontal plane, for example. Now they have kept the square pyramid like this. Now from the top view how the object will going to look, that is very much important. If I view the object from the top, the object look like a square in the square shape. I am correct, you can clearly observe here. Now I am going to keep the object like this. From the top, observer point of view, you can clearly observe here it look like a square face. Now I am writing the object's top view of sides 35 mm. With the help of a scale I am drawing a line of sides 35 mm. Now from the top view we can clearly observe that all these slant edges are clearly visible for us, but those slant edges are look like the diagonal lines in the top view. Now I'll go for dimensioning it. Of sides 35 mm. Now I'll go for giving the naming for it. From all the corners I'll go for giving the naming. This is the pyramid. I'm going to call this corner as A, this as B, this as C, and this one as D. Now here from the apex point to the midpoint of the base, the axis is present over that, but in the top view it is not visible for us, even though I am indicating the axis point as O1. Next I'll go for the drawing the front view of the object, means it is resting on HP. Based on that I have written the top view of the object. Next we'll go for in the same position we should go for writing the front view of the object. While writing the front view of the object, I'll go for drawing the projection lines. Okay, these are the projection lines to generate the front view of the object. And one more thing, here I have written the top view with the pink color or in the dark color because here all the edges are clearly visible. It means all the edges are clearly visible. In pyramids, in the top view, even the slant edges and also the base edges are clearly visible. Next I'll go for the construction of front view. Before going to the construction of front view, in the question they are given the axis length of 65 mm. Many of the students will get confused with the axis length and the slant edge length. Means in all the pyramid problems they will go for the axis length. No, they will not going to mention any of the slant edge length. Means from the axis length means here I need to draw the axis of length 65 mm according to the scale. This axis line should be a chain line indicated with the dashes and the point in between the line. Now it is of length of 65 mm according to the question. Now from here I am going to draw the slant edges of that particular pyramids. Okay, this is the front view of the object. Now I'll go for the naming. In the front view, A dash and D dash is not visible for us within the brackets. Again, B dash is visible for us, C dash is not visible. Again, I'm going to call this as O1 dash, this point as O dash. Again, here you can clearly observe the object here. It is resting on HP. From the front view, only this triangular face is clearly visible. That is nothing but A, B, O. Triangular face is clearly visible for us in the front view. After projecting it, you can clearly observe here. They written the color line means those are visible edges, and in between it the axis is present over here. In between the axis is present here, I have written that axis. This is about the construction of the first position. Next, we are doing the change of position method. The object, the first position is over, writing the top view and front view is over. Next is about the object is get inclined to HP at 45 degree. You can clearly come to know that thing in the question. Draw the projection of the pyramid when the axis is inclined to HP at 45 degree. Means in the problem they are clearly saying that axis is get inclined at an angle of 45 degree. This is very much important for us to go for the second position. Here the axis is get inclined to HP at 45 degree. Now the axis is present exactly at the center. It is getting inclined to HP at 45 degree. For example, if I consider my left hand as an horizontal plane, now the solid will be like this. In the second position, the axis of the solid is get inclined at an angle of 45 degree to HP. Now how to construct it? For the construction of that particular second position, you can clearly observe here. One of the key point is nothing but here the slant edge is present. It's very difficult to go for the writing the second position of that particular front view of the object. To overcome that issue, here they given the angle with reference to the axis to HP. For that, here the axis of the solid is at an angle of 90 degree to the base edge of the solid. You can clearly observe this is a vertical line which is get inclined at an angle of 90 degree. By knowing that, there in the question they are asking you should get inclined at an angle of 45 degree. To overcome this issue, I am going to rotate the base first to an angle of 45 degree. Then with the help of compass, I am going to measure the distance of the sides. Then I will go for cutting the R. For that, you can observe here, I am going to measure the base edge length and I am going to draw an inclined line at an angle of 45 degree. At an angle of 45 degree to the horizontal plane. Now I'll go for indicating the corners. whatever the names I have given for it. Next, after this is over, don't worry about the axis inclination. Next, I will go for measuring the side length from slant edge length to the apex point A dash to O dash, or from O dash to B dash. I will go for measuring it. If one time measurement is enough, because here the length and whatever the length present over at the slant edge both are same, I will measuring it. I will come to A dash point, I will going to cut an arc over here. I will come to B dash point, I will going to cut an arc over here. That will going to create the apex point, O dash point. Now it is very easy for me to go for drawing the inclined line. Now after completion of this, now axis is required for us to generate that axis from the center of the O dash exactly to the midpoint of it. I will go for drawing the chain line. Now if I measure this angle, it is exactly 45 degree. Okay, now here they given the axis inclination, but I have made the edge inclination because the axis is get inclined at an angle of 90 degree to the base. Based on that, I constructed this. Next, I will go for the projection of the second position, that in the top view, by drawing the projection lines from the top. Again from the top view in the first position. Now I will go for the thin lines here. Again from O dash point, I am drawing the projection line. Again from the axis, I am drawing the line. Again from the O1 dash. Now I will go for the indicating the points. This is D, this is A, this is B, this is C, this is O. Okay, now after completion of this, we need to go for drawing the object in its top view. Now after drawing the object, we can clearly write whatever the edges present over there, we can join it. But a concept is there for drawing the visible and invisible edges. Means here we are writing the top view of the object by inclining the object to 45 degree. Now while writing the top view of the object in the second position, the first concept is about the, I am viewing the object from here, means the observer is here, we are viewing the front view of the object to write the top view of the object. The first case is outermost edges are visible. Outermost edges are visible, that are nothing but the boundary lines are visible, especially in this case it is visible in the top view. Outermost edges are visible in the top view. These are the outermost edges. Outermost edges are visible in the top view. These are the outermost edges of this particular top view of the object. Next concept is the observer is viewing the object from the top, means I am viewing the object from here to write the top view of the object. Means second one is about the faces and edges near to the observer are visible. The faces and edges near to the observer are visible, and the faces that are not near to the observer, that are not visible. Here you can clearly observe here in the diagram from the top, the edges and the faces that are clearly visible is A dash, D dash and O dash. Means one of the triangular face which get connected to the base edge is clearly visible for me. I will come to the top view now. Means A dash to O dash, A dash to O dash is clearly visible. D dash to O dash is clearly visible. Means these are the faces and edges near to the observer that is clearly visible in the top view. Next, one more concept is there, that is nothing but the edges that are present above the axis are visible. Even that is also get overcome in the second case itself. From the axis, the above edges are also visible. That already come across in the second point itself. Now the only invisible edge that is present is nothing but the resting edge. Here B dash and C dash is the resting edge that is not visible from the top view. We can clearly observe here by rotating the object like this. If I look from the top, it is not clearly visible for me. That is the only invisible edges in this particular case. And I'll go for drawing the axis line. This is O1. Now to check the visible and invisible edges, the first concept is outermost boundary edges are clearly visible, or outermost edges are clearly visible. For me, O, C, D, A, B, O is the outermost edge. And the second concept is the from the top view, the faces and edges near to the observer. If I looking from the top view, this face is near to the observer. Means for me this face is nearer. Based on that, O dash to A dash to D dash, again D dash to O dash. Means the triangular face is clearly visible for me. Again by that concept, I drawn in a dark line from O to D and O to A. Next is the one edge is not clearly visible for us. That is nothing but the resting edge, because for that resting edge, A dash and D dash edge is opposite to it. It is not clearly visible for that. Because of that, I have written in dashes lines. Next is about the how to write the last position of this particular solid. Now I completed the first position, I completed the second position. Now I will moving for the last position of the object. While moving to the last position of the object, you can clearly observe in the question, it is resting on one of its edges on HP. It is resting on one of its edges on HP of the base, which is inclined to VP at 30 degree. This is very much important. I already underlined it. Means here you can clearly observe here 4 edges were there, but it is resting on BC is clearly come to know about it in the second position. Some of the students will going to ask, sir, why we are rotating the pyramid only in the right direction? Why not in the left direction? That condition is also possible. If while constructing the object, you can go in this direction or you can go in this direction. Means instead of constructing to the right side, you can construct to the left side. It is also possible, because they are not clearly mentioned which edge is located or resting on HP. They are given that one of its base edges are resting on HP. Based on that, I rotated the object towards the right side of the solution. Because of that, B dash and C dash is the resting edge for me. For now, next I'll go for constructing the last position. While constructing the last position, first I'll go for drawing the inclined line of an angle of 30 degree. Thin inclined line at an angle of 30 degree. Next, I'll come to the second position. Don't go to the first position. It is totally wrong, because once after writing the top and front view of the first position is over, we coming to the second position. Once after coming to the second position, next in the last, to get the last position, we are tilting this object to the next position. Now here, while writing the third position, you can clearly observe here, in the first position the object is like this, front view, top view is over. Next, in the second position, it is resting on B and C like this. And in the last position, now I am rotating this object to an angle of 30 degree with reference to the vertical plane. This board is the, if I consider this board as vertical plane, the object is get rotated like this. First, the object is like this. Now I am rotating like this. To vertical plane, it is get rotated an angle of 30 degree. Means here the inclination is reference to the vertical plane. Don't get confused. For that, I am rotating the second position object. I am not rotating the first position of the solid. I am rotating the second position of the solid. Now I will come to B and C. I will know the B and C length. I am going to measure it. B and C length, I am going to measure it. I am going to measure the B and C length. Okay, once after measuring the B and C length, I will go for this is B point, C point, this is B point, because I am rotating to the vertical plane at an angle of 30 degree. Next is about how to construct the remaining edges of the solid in the second position. To construct that, now you can observe here, we will go with the compass, or you can go with the diagonal method, or you can go with the help of protractor. If you people go with the diagonal method, they will going to measure from A to C or from D to B. If I measure from A to C, from C point, this is C point, I will going to draw an arc to this point. Again, I will come to B point, I will going to draw an arc to this point. That is also possible. Next, to overcome for the intersection of R, I will come to again C to D or from A to B. This also possible. In some of the students, they will keep the protractor here at the C point, because this is a 90 degree angle lines. These two lines are, they will go to mark 90 degree over here, again 90 degree over here, they will going to draw a line. It is left to you people. It's purely based on geometric construction. Now if I go for diagonal method, I am measuring A to C or from B to C. From C point 1 arc towards this side, again from B point 1 arc towards this side. Again I will come to side length of C to D. I will measure C to D. From C I will intersect this arc. Again from B I will going to intersect this arc. Now it is over. Now this is the points D for me and A for me. Now how I written over there in the same manner, I am writing the object. Now this is A, this is C. Now how to get the O point? It's very simple. Whether you can measure from O to C or from O to B or from O to D or from O to A. I will measure from O to C. Then I will going to cut an arc over here. One arc from C point, one arc from B point. Because the length from O to C and O to B will be same. Now I am joining this. Okay, once after completion of it, next I should go for drawing the axis length. Draw the axis length. I will come to D to O1 or A to O1. Because both these side lengths will be same, or both the dimensions are same. If I measure from D to O1 or A to O1, from D to O1 I will going to cut an arc. Again from A to O1 I will going to cut an arc. Then I will go for joining this axis length. This is O1, this is O. Now I am transferring this second position object to the last position. That is get inclined at an angle of 30 degree. Now I need to go for constructing the front view of the object. Now the object is get tilted like this. I should go for drawing the front view of the object. While drawing the front view of the object, the observer is clearly present over here. Is nothing but here. From the observer, we are writing the front view of the object. First, I will go for projecting the lines that are necessarily required for me to draw the front view. First, I will go for the D point. I'm starting here. Again I am drawing the projection line from here. This is D dash. Again I will go for C point. C point is available for me here itself, that is nothing but C dash. Again I will go for B point. B point is available here, that is B dash. Again I will go for A point. A is available at the top, this is nothing but the A dash. To get the front view of the object, I am drawing the projection lines. I am showing the arrows here to the respective points. Again to get the O point, I am drawing a projection line from this side. Again the same line is drawn to the top. This is my O dash. Again in similar fashion, to get the axis, I am drawing a projection line where that will going to meet the front view of the object in the second position. Again one more line. This is my axis. Okay, now the drawing the projection lines is over. Next we should go for applying the visible and invisible concept. The first concept is outermost edges are visible. I am going to start from O dash. O dash to D dash, D dash to C dash, again C dash to B dash, again from there to O dash. This is the first concept, outermost edges is finished. Next concept is faces and edges near to the observer are visible. Now if the observer is present over here, you can clearly observe that the base is clearly visible. If the observer is present, because I am inclining this object to 30 degree, based on that the base edge is clearly visible. That base edge is nothing but A, B, C, D. Now at the top again A dash to D dash is the one of the base edge. D dash to C dash is one of the base edge. C dash to B dash is one of the base edge. Again I am going to connect this. Means to the observer the base edge is clearly visible because it is near to the observer. And one more thing is about to the observer, O to A and O to base near to the observer according to the second concept. Means the edges that are near to the observer are clearly visible. Means O to B already is visible, O to A is one more edge that is clearly visible according to the second concept. And one more edge that is completely left, that is nothing but the hidden edge or the invisible edge, that will be indicated with the dotted line. Okay, now and after indicating with the dotted line, one more is present, that is nothing but the axis. Now if I draw it here, for me the axis is completely coming over here. Now I am going to join this like this. Means for me it is not exact to the scale. If you people draw it exact to the scale, the things are clearly visible for you people. Means the axis is separately clearly visible, and also the hidden edge is clearly visible for you people. This is regarding about how to construct the object in three different views, when it's come to the first position, when it's come to the second position, when it's come to the last position, with the help of using the visible and invisible concepts. Thank you.